Hey guys, we got some really cool questions here. It says some cool questions. I hope you guys enjoy these questions. They're actually coming from a BC overview, and I think they pertain to us because a lot of these questions we can do. They're just a little tougher than your typical AB questions, but we can do them. So let's get right into it. So let's see. So I have time and velocity q. So it looks like these are velocity, and it looks like over here I have acceleration. So let's read this. The table above gives selected values of the function v of q, which represents the velocity of particle q traveling along a horizontal line between 0 and 10 seconds. Or, it doesn't give us units, but between 0 and 10. Let x subscript of q and a of q denote the position and acceleration of particle q at time t. It is known that your initial position is 9 when time is 0, and that acceleration is always negative on the interval 0 to 10. Particle r travels along the same horizontal line as particle q, and its acceleration is given by the graph shown at the right between 0 and 10. The portion of the graph y equals a of r on the interval 2 to 6 is a semicircle. So it's obvious right here. It looks like a semicircle. Let's see. The portion of the graph on the interval, I already read that. On all other portions, the graph is a piecewise linear. X of r and v of r denote the position and velocity of particle r at time t, respectively. It is known that x of 7 equals 20. I wouldn't call that initial position because it's not 0, but it's a position that they give us, so I guess you can refer it to as initial position if you want. I was just going to say position at 7 and velocity at 7. Letter A. How much greater is the average acceleration of particle r than the average acceleration of particle q on the interval 0 to 6? All right, so to find average acceleration of particle q, they give us a table, and notice that the table is velocity. So average acceleration is just going to be like your average rate of change, guys. So you're just going to do y2 minus y1 over x2 minus x1. Just finding slope, the average slope. But notice when we find the average acceleration of r, they give us a of r. And for this one, we're going to have to use the formula, your integral formula. 1 over b minus a, integral from a to b of your a of r. So understand when you do what depending on what situation you have. So let's go ahead and find the table one first, guys. So I'm going to write average of acceleration of q is going to be equal to, so let's say it's between 0 and 6. So I need this guy and that guy. So I need v of 6 minus v of 0 divided by 6 minus 0. V of 6 was 3. V of 0 is 10 over 6 minus 0. I don't need a calculator for this one. That looks like that is just negative 7 over 6. And I don't have units, so I'm not going to put units in it. So that's my average acceleration for q between 0 and 6. Now for r, I have this table here. I have this graph here, sorry. So I need to find the area under this curve. So average for r, so a of r, is going to be equal 1 over 6 minus 0 integral from 0 to 6 of a of r dt. So let's see what that is. 1/6, and then I'm doing this part here in bracket. So I see a trapezoid right there. So my first trapezoid, 1 plus 4, and then my height is 2 divided by 2. So those 2's are going to cancel out. Plus, now here, I'm going to have to find this rectangle first, and then I'm going to subtract the semicircle. So the rectangle, the difference between 2 and 6 is 4, 4 and 4, so that's 16. So I'm going to go, and I'm going to write 16 minus, and then remember how we got that 16, that's just 4 times 4. And then I'm going to take away this semicircle here. So let's see, pi times the radius is 2 squared divided by 2 because it's a semicircle, and there it is. That's it. And yeah, you can actually leave it like that, guys, but let's go ahead and continue. We're good enough to continue. Let's see, 1/6 plus, if I drop those parentheses, let's see, these 2's cancel out. 4 plus 1 is 5 plus 16 minus 2 pi. And we get 1/6, 16 and 5, what's that, 21? So 21 minus 2 pi. And I guess to finish it off, we have 21 minus 2 pi over 6. So that's the average acceleration of r, and Here's the average acceleration of Q up here. So Q and R. But they don't want to know the average acceleration of both. They want to know how much greater. So if you want to know how much greater, we just subtract the two suckers. So we're going to go 21 minus 2 pi over 6 minus a negative 7, 6. And I think they're being nice to us by having the denominator be 7 there. So minus times the negative. Negative times the negative is a positive. So 21 plus 7 is 28. So 28 minus 2 pi over 6. And you can actually leave it like that, guys. This is how much more greater it is. But I see that they're all even. So a better number is 14 minus pi over 3. I just reduced everything by 2, guys. And then we're just going to say A of R is 14 minus pi over 3 greater than A of Q. And there it is, full credit. All right, let's go to the next question. I like the idea of having the stem of the problem there again and then just asking the next question. So I think I'm going to start doing that for my assignments as well. Find the value VR of 0. So I'm looking at this, guys. So I'm going to have to find the area under the curve. Actually, maybe not. Let's see. Yeah, I am, because they give me, what do they give me? They give me the velocity at 7, at time t equals 7. So I'm going to have to find the area between 0 and 7, which I already have the area between 0 and 6. So I just got to do just that one little trapezoid. And the reason for that, guys, is because area under an acceleration curve is going to tell you the change in velocity. So here we go. I'm going to write VR of 0 is equal to VR of 7 plus the change in velocity from 7 to 0 of, well, this is the change in velocity right here. So there it is. That gives me my change in velocity. So let's go ahead and do this, guys. I'm going to put equal sign. VR of 7 was 4. So write 4 plus, and I guess I should, since I'm counting backwards, I'm going to put a negative in the front here like that, guys. Now, I already know what area under the curve from 0 to 6 was. So area under the curve from 0 to 6 was, let's see, what was it? 21 minus 2 pi. I have it right here. I have it right here. So 21 minus 2 pi, that was area under the curve from 0 to 6. So I'm going to put that in here, guys. So 21 minus 2 pi plus, so all I got to do now is just add up this right here in red. So let's see, this region, that's a 4 plus, this guy's a 2, put parentheses on those. My height is technically 1, divide by 2. So there it is, whatever that is. And yeah, let's go ahead and solve it, guys. So we can do that. Let's see, 4 minus, and let's see, 4 plus 2 is 6. 6 times 1 is 6. 6 divided by 2 is 3. 21 and 3 is 24. 24 minus 2 pi. And I'm going to distribute that negative. So I get 4 minus 24 plus 2 pi. So negative 20 plus 2 pi. There it is. That's my velocity at 0. So if you want to write velocity of r at 0, it's just negative 20 plus 2 pi. You don't need to write a statement. They just said find the value. There it is. Done. Okay, let's go to the next one. It says approximate the value of xq of 10 using a left Riemann sum with 5 subintervals indicated by the data in the table for v of q. Is this approximation less or greater than the true value of xq of 10? Explain your answer. Okay, so they're asking two questions. Let's first find the first one. So xq of 10 is equal to, let's see, what do they give me? They give me the position at 0. Perfect. So xq of 0 plus the integral from 0 to 10 of v of q. Now, this right here gives me my displacement, guys. Now, they want me to use LRAM, left Riemann sum. So, I'm going to use left Riemann sum. And all we're doing, guys, is just finding our rectangles here. They said to use 5 of them. 1, 2, 3, 4, 5. Yeah, we have 5 rectangles there. So here we go. I'm going to zoom out just so I can see my values that I'm going to be putting in. So let's see. The first one, this is my position, 9 plus, and here we go. Everything that's in bracket is my LRAM. My first rectangle. So my width is 3, and my height, they want me to use LRAM, so I'm going to use 10. So I'm going to keep this pattern 3 times 10 plus my next triangle, 3 times, the difference between 3 and 5 is 2. So 2, and then I'm going to use that 7. Plus, the difference between 5 and 6 is 1, and I'm going to use that 4. Plus, the difference between 6 and 7 is another 1, and I'm going to use the 3. Plus, the difference between 7 and 10 is 3, and I'm going to use the 2, and then close the bracket. All right, let's see what this is. I got my little calculator here. Let me zoom out so I can... There we go. And then I'm just going to type it in. I guess we don't really need it. We can probably just figure it out just by adding. Let's see. 3 times 10 is 30. Plus 2 times 7 is 14. Plus 4. Plus 3. Plus 6. So I get 66. So x of q at 10 is 66. Okay. So now, let's zoom back in. Now to answer the second question. Is this approximation less than or greater than the true value of x cubed of 10? Explain your answer. All right, so here's where this is going to come in. The acceleration is always negative, guys, always. So that means my velocity is always decreasing. So you have something like this, velocity, and it doesn't matter if it looks like this or if it looks like this. It's always decreasing regardless. And if you do an LRAM, on a decreasing curve, regardless of how it looks, it's always going to be an over approximation. Do we see that, guys? Yes. Well, I can't hear you guys, but I'm imagining you guys are saying yes. All right. So because I'm doing an LRAM on a curve that's decreasing, I'm always going to get an over approximation. I hope that makes sense. So I'm going to state why. So I'm going to write since acceleration a of q. A of q. I always forget that it's capital Q, not little q. Since a of q is negative on entire interval, LRAM will give an over approximation. Since acceleration is negative on entire interval, LRAM will give an over approximation. I think that's perfect right there. And there it is. Done. All right, let's go to the next question. Let's see. The table gets like, oh, we already read on. Is it true that particle Q meets particle R at some time on the interval 7 to 10? Explain your answer. Okay, we already know. All right, let me read that again. Is it true that particle Q meets particle R at some time on the interval 7 to 10? Explain your answer. Okay, we already know that this is an over approximation. This is the biggest particle Q is going to be. So now we need to find the smallest particle Q is going to be. So particle Q, so I'm just going to write x of Q. The biggest it's going to be is 66. What's the smallest it's going to be? So we're not going to do, you're not going to find your, let's see if I can explain it up here. We're not going to find, we're not going to do RRAM all the way to 10 because that's just going to give us a number smaller than 66. I want the absolute smallest number. So I'm going to find it at 7, if that makes sense. So if I were to do RRAM, I'm going to stop. Let's see, I'm going to go, this is just if I were to do RRAM, guys. So I'm going to go RRAM. Everything in blue is an RRAM. So let's see, 3 times 7 plus 2 times 4 plus 1 times 3 plus 2, 1 times 2. And that's it. I'm going to stop right there. Let me tell you why. I guess I can tell you right real quick. So if I do this right here, this is going to give me the smallest possible for 7. And you'll see right now. You know what? I'll even do the smallest possible at 10. And you'll see what I mean. So let's see. I'm going to take out my little calculator here. And I'm going to go 9 plus 3 and 7. What's that? 21. 21 plus 8 plus 3 plus 2. And we get 43. And if I were to do one more, so let's say I were to do from 7 to 10. So I would have been 3 times 1, 43. So that would have been 46. But which one's the smaller number? The 43 or the 46? Yeah, the 43. So I know, and because, look, the velocity is always positive, so I'm always moving to the right, no matter what. You're always moving to the right. So I cover all the values from 43 all the way to 66. And yes, you can put 46 if you want, but 43 is smaller. So just use the 43. So now, that's for x of q. Now I need to find x of r. So x of r, let's see, x of r, the smallest it's ever going to be is right there, 20. See, so you guys see what I'm trying to do here? All I care about is, does x of r, is that value somewhere between 43 and 66? So if the highest value is a 70, then yeah, of course, somewhere down the line between 7 and 10, they're going to meet. Maybe, it's a maybe. All right, so let's figure this out. I know that x of r at 7 is 20, and my velocity at 7 is 4, so I need to figure out the distance traveled. So it doesn't look like you're going to be able to figure it out from going backwards here, guys, but I do know that my acceleration is always 2 between 7 and 10. So here's what I'm going to write. A of r is always 2 as long as t is between 7 and 10. So if I go backwards, so let's see, v of r, let me write v of r of t. V of r of t is equal to 2t plus c. You know what? I'm writing too big. That way I don't have to write so big, guys. V of r of t is equal to 2t plus c. And I know that at 7, my velocity is 4. So 4 equals 2 times 7 plus c. 2 times 7 is 14. So 4 equals 14 plus c. So c has to be negative 10. So from that, I get v of r is equal to 2t minus 10. So now I'm going to do another antiderivative. xr of t. So here's my position equation, guys. So 2t, add 1, divide by 2. So that means t squared minus 10t plus c. And then I know it at 7 again. At 7, I am 20. So 20 equals 7 squared, so 49, minus 10 times 7 is 70, plus c. 49 minus 70, 50, and 70 is 20, so that's 21. 21 plus c. So now negative 21. Plus 21, c is 41. All right, so from that, I can tell that my x of t, or x of r, sorry, x of r of t has to be equal to t squared minus 10t plus 41. All right, let's figure it out. Let's see what this is at 10. xr of 10 equals 10 squared is 100, 10 times 10 is 100, 100 minus 100 is 0, I get 41. So now look, I know this is a max, well actually we know this one. This is actually specific. This one at t equals 7 is 20, and at t equals 10 is 41. I know that at 10, this is an over approximate, and I know that at 7, this is an under approximate. But I know for a fact, if this is an under approximate and this is an over approximate, I know that x of q must be between there. It must. And I know that x of r definitely goes between there, because this is exact at 7 and this is exact at 10. Now, are those numbers within range? No, they're not. So I'm going to write since 43 less than xq less than 66 and 20 less than xr less than, you can actually put equal signs on this one, 41, because it does equal 41, it does equal 20, comma, no, and let me, q and particle r do not meet on some time between 7 and 10. No, particle q and r do not meet on this specific time interval. And if you want to put the time interval, you can. But you already said the word specific, so they know that you're referring to this guy. All right. I hope that one made sense. That one was pretty tough, guys. I'm not going to... yeah, that one was pretty tough. You have to think a lot about it. All right. Let's go to the next one. Some values of the function f, whose derivative of all orders exists, are shown in the table below, along with some known values of f prime, f double prime, f triple prime, and f to the fourth. So the f to the fourth means the fourth derivative, as well as g of x equals x f prime of x. Letter A. Find the value as limit approaches 1 of all this stuff. Okay, first thing I'm going to do, direct substitution. I can already see, guys, look, I'm looking at f of 1. F of 1 is 3. 3, and then minus 6, that's a negative 3, plus 3 is 0. So immediately I'm thinking this is either going to be a 0, the answer is either going to be 0 or it's going to be 0 over 0, and I'm going to have to do L'Hopital's rule. I'm going to see if the bottom's the same way. So f prime, let's see, if I plug in a 1, that's f prime of 2. F prime of 2 is, where are you? Here's 2. F prime of 2 is 3. 3 times 3 is 9. And then look, cosine of 0 is 1, so I get a 3. So 9 minus 3 is 6. And then look, that's a minus 6. So 6 minus 6 is 0. Yes, guys, this looks like 0 over 0. L'Hopital's rule all day. So I'm going to first write them out. You have to show that both are 0. So limit, by both, I mean numerator and denominator. Limit as x approaches 1 of f of x minus 6x plus 3 equals f of 1 minus 6 plus 3, which equals 3 minus 6 plus 3, which equals 0. And then I got to show the other one. Limit as x approaches 1 of 3f prime of 2x minus 3 cosine 2x minus 2 minus 6x equals, so let's see, 3 times 3 minus 3 times 1 minus 6 times 1, which equals 3 times 3 is 9, minus 3 is 6, minus 6 is 0. So I can use L'Hopital's rule. So using L'Hopital, so here we go. Limit as x approaches 1, so the derivative of the top. So f prime of x minus 6 over, and I'm going to take the derivative of the bottom. So the derivative of this right here, guys, is going to be, look, chain rule, 3f prime prime 2x times 2. So 6 f prime prime 2x minus, again, chain rule, the derivative of cosine is a negative sign. So negative sign, the negative is a positive. So 3 cosine 2x minus 2 times 2. So 6 sine 2x minus 2 minus 6. All right, so now let's see if we can go ahead and do this, guys. So I'm going to plug in a 1, f prime of 1. F prime of 1 is 6. 6 minus 6 is 0. It looks like I'm going to do it again. I'm going to put it here on the side. Let's see, f prime prime of 2. F prime prime of 2 is 1. 1 times 6 is 6. Sine of 0 is 0. 6 minus 6 is 0. Again. Wow. Okay, so you're going to have to do it again, guys. So I'm going to write it here on the side. Limit as x approaches 1. You're going to have to do f prime of x minus 6 equals f prime of 1 minus 6, which equals 6 minus 6, which equals 0. And then limit as x approaches 1 of 6 f prime prime of 2x plus 6 sine 2x minus 2 minus 6 equals f prime prime of 2 was 1. So 6, oh, I don't know why it does that sometimes. 6 plus 0 minus 6, which is 0. So we're going to use L'Hopital again. So here we go. One more time. Limit, and you know what? I should probably color code all the different times. So we've done it twice already, guys. Limit as x approaches 1. So f prime prime of x over, so again, chain rule, 6f prime 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 of 2x times 2, so that's going to be 12 f prime 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 of 2x. Let's see, plus the derivative of sine is cosine, so, and then times 2 because of the chain rule, plus 12 cosine 2x minus 2. And it looks like we will be good, I hope. All right, here we go. Let's plug in a 1. So f prime prime of 1 is f prime prime of 1 is 8. And then f prime 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 of 2, f prime 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 of 2 is 4. And then 4 times, so 12 times 4 plus, let's see, if I plug in a 1, that's a plus 12. 12, 24, 48, so 8 over 60. And what does that reduce to? 8 over 60, 2 over 15. So there we go, guys. Sorry about that. All right. Of x, I have to do product rule. First times root of the second, f prime prime of x, plus second f prime of x times root of the first, which is just 1. So there it is. So g prime of 2 is equal to 2 times f prime prime of 2. F prime prime of 2 is 1. If I did that correctly there. Plus f prime of 2. F prime of 2 is 3. So it looks like it's 5. I don't see any mistakes. Let me just make sure. Yeah, we're good. So now that I got that going on, here we go. Here's my tangent line. Y minus 6 equals 5 parenthesis x minus 2. That's my tangent. I'm going to use it to approximate 26. If you want to distribute, you can. I'm going to go ahead and do it like this, guys. I'm just going to say g. Oh, there's a y that. I need it to approximate the solution to the equation g of x equals 26. Okay, so g of x. So here's my linear line. 5x minus 10 plus 6. So g of x is approximately 5x minus 4. As long as you're really, really close to x equals 2. Around x equals 2. All right. So now I want to set that equal to 26. So 26 equals 5x minus 4. Plus 4 plus 4. So 30 equals 5x. Divide by 5. X equals 6. So there it is, guys. I hope we enjoyed it. BC guys, I hope you guys enjoyed it. So I know you guys have been wanting a long time for a video. I know we haven't finished letter C and D. Letter C asks for a Taylor, and then letter D asks for an approximation of an integral using partial integration by parts, maybe. I didn't take a good look at it. I should have. But I know that one of them was a Taylor series. Excuse me. So hopefully we'll go over, excuse me again. Hopefully we'll go over that before this weekend. And I hope you guys are happy with your education, guys. All right. Later, guys. Bye.